Hi dear students, welcome to another wonderful session. Today we are going to deal on the topic on the chapter acids, bases and salts. Coming to acids and bases, we have been studying about this from our previous classes. So what is the first definition you have heard? What is an acid? What is a base? Acid is sour in taste and changes the color of blue litmus to red. Base is slippery to touch, bitter in taste and change the color of red litmus to blue. That is the proper definition or the first definition we have heard about acid and a base. In this chapter, we are going to deal about much further details on the topic acid, base and salts. For that, we need to refer certain points like indicators. So what is an indicator? As the name suggests, indicator is something that indicates what is the solution about or which depicts the description of a solution. So coming to indicators, we have different types of indicators: litmus solution, litmus paper, methyl orange, phenolphthalein. These are the four different categories of indicators that you need to study. Coming to litmus solution. It is a purple color solution that turns red in acid and turns blue in base. As you can see in the picture, you can see that. Coming to litmus paper, a blue litmus paper turns red when dipped in an acid. A red litmus paper turns blue when dipped in a base. As you can see in the picture, the first one is an acid. We are dipping a blue litmus paper into an acid, it is turning red. Similarly, we are dipping a red litmus paper in a base which is turning blue. The next indicator is methyl orange. This particular indicator turns red in an acid and turns yellow in a base. And coming to the last one, phenolphthalein. This is really colorless in an acid and shows pink color in a base. So these are the four different type of indicators that you have to study now, which is very well broadly classified into higher and higher categories, which is confined to you. Summarizing the topic, as you can see, an acid turns red in a blue litmus solution. It does not have any characteristic change in red litmus solution. In methyl orange, acid turns red. In phenolphthalein, acid is colorless. Similarly, for a base, it does not show any characteristic change in blue litmus solution. In red litmus solution, it turns blue. In methyl orange, it is yellow. And in phenolphthalein, a base is pink. Now, let's go to the next topic. How do acids and bases react with metals? You all know metals are certainly reactive. But how do they react with acid and a base? So coming to a general reaction, as you can see here, acid plus metal gives salt and hydrogen gas. This takes place in such a way that a metal displaces hydrogen from the acid. The remaining part of the acid and the metal combines to form a salt. As an example, as you can see, this is from your textbook. When zinc granules are added to a solution of sulfuric acid, hydrogen gas is liberated. A delivery tube is connected to a salt solution, which is a soap solution here, from which the presence of hydrogen gas can be very well detected by bringing a candle over the fumes. It will start to crack. This shows the presence of hydrogen gas. So, an acid and a metal reacts together to form a salt and hydrogen gas. So, in the case of zinc and sulfuric acid, zinc plus sulfuric acid gives zinc sulfate plus hydrogen gas. Similarly, in case of a base too acts like as an acid. Base plus metal gives salt plus hydrogen gas. Similar in the case of an acid, a metal can also displace hydrogen from a base. For example, when zinc granules are added to a solution of sodium hydroxide, hydrogen gas is liberated. Here, sodium zincate Na2ZnO2 is the salt formed. Next, another broad classification. How does acids react with metal carbonates and metal hydrogen carbonates? Metal hydrogen carbonates are also called bicarbonates. Here the general reaction is acid plus metal carbonates or metal hydrogen carbonates gives salt plus carbon dioxide plus water. Here there are three byproducts. When a solution of HCl is added to sodium carbonate or sodium bicarbonate taken in a test tube, brisk effervescence is observed. A brisk effervescence is the detection of carbon dioxide in a particular reaction. This is due to liberation of CO2. Also, the conformation of the CO2 is done by just passing that gas through lime water, which is calcium hydroxide. The lime water will turn milky. As you can see here, Na2CO3 plus HCl gives NaCl plus CO2 plus H2O. CaOH twice, calcium hydroxide plus CO2 gives CaCO3, calcium carbonate. This is the white precipitate that you are seeing in the picture plus water. So, the conformation test for carbon dioxide, which means carbon dioxide is liberated here, that is confirmed by passing lime water, which turns the lime water milky, converting CaOH twice or calcium hydroxide into calcium carbonate. Next, metallic oxide and acid. As you can see, the general reaction is acid plus metallic oxide giving salt and water. Let's look with an example. When a small quantity of dilute HCl is added to a pinch of copper oxide powder, as you can see in the picture, the solution becomes blue-green and the copper oxide dissolves. This blue-green is due to the formation of copper chloride in the reaction, as you can see here. Now, let's check once again. Acid plus metal oxide giving salt and water. Here, we now just studied acid plus base gives salt and water. So, a metal oxide can be treated as a base. Next, non-metallic oxide and a base. The general reaction is base plus non-metallic oxide gives salt and water. Let's again check with an example. CO2 is a non-metallic oxide, carbon dioxide. Carbon is a non-metal. When CO2 is passed over calcium hydroxide, it is a base. Calcium carbonate is formed. Again, a base plus non-metallic oxide is giving a salt and water. So, as discussed just now, a non-metallic oxide can be treated as an acid. Next, what do acids and bases have in common? This is the main broad category you have to study when you are dealing with acid and base. Dealing with an acid, hydrogen is the common entity in all acids. Hydrogen chloride, HCl, sulfuric acid, H2SO4, nitric acid, HNO3, all these have hydrogen as a common entity. Now, just look at the picture. This is a simple picture where a solution of acid is allowed to conduct electricity and we are glowing a bulb. As you can see here, when a current is passed through an aqueous solution of an acid, it conducts the current. What does this mean? This means that there is a flow of electricity and electric current through the solution. This current is carried by ions, which is hydrogen ions. These are the hydrogen ions, which is also called the H plus ions, which is only produced in the presence of water. This can be very well explained with another example. Just view this picture. When NaCl crystals, sodium chloride crystals, are taken in a boiling tube, and when concentrated sulfuric acid is added to it, HCl gas is liberated. Let's take two different types of litmus papers, a dry and moist, blue litmus papers. When one by one, first I am bringing a dry litmus paper here, but here no litmus color change occurs. But when I bring a moist blue litmus paper over the liberated hydrogen gas, the blue litmus paper turns red. This depicts that the ions, which are the hydrogen ions, is only produced in the presence of water. This means that hydrogen ions in HCl are produced in the presence of water. The separation of hydrogen ion from HCl molecules cannot occur in the absence of water. which means that water is a necessary entity, water is a necessary condition. As you can see here, HCl plus H2O is giving H3O plus, which is called the hydronium ion plus Cl minus. Hydrogen ions, which means the H plus ions, cannot exist alone, but they can exist after combining with water in H plus aqueous state or in H3O plus hydronium state. Similarly, when a base is dissolved in water, as you can see, sodium hydroxide is dissolved in water. NaOH plus H2O is giving Na plus OH minus. Bases generate hydroxide ions, which are also called OH minus ions in water. All bases does not dissolve in water. Those bases which dissolve in water are called alkalis. In the same case of hydrogen ions, OH minus ions shows its predominant capacity or predominant power in the presence of water. Now, let's look at the neutralization reaction, which means acid-base reaction that is forming salt and water here. Just look at the picture. Acid plus base is giving salt and water. HH plus MOH is giving MH plus HOH, which means H plus OH minus is giving H2O, which means the hydrogen ion H plus from the acid and hydroxide ion OH minus from the base combines together form H2O, which is water, which is we get in the neutralization reaction as a product of acid plus base reaction. Next topic, mixing water with acid or a base. This is the most important topic or the most important thing we need to study while dealing with an acid or base in a laboratory. The process of dissolving an acid or a base in water is highly exothermic. We have studied what is an exothermic reaction. It is a reaction in which heat is liberated or heat is released. A large amount of heat will be liberated in this case. Always the acid must be slowly added to the water with constant stirring. If water is added to acid, the heat generated would cause the mixture to splash out and cause burn. This is really dangerous. So always we must be careful that the acid must be slowly added to the water with constant stirring. Mixing an acid or base with water results in decrease in concentration of the acid or the base. This process is called dilution. Next, strength of an acid or a base. The strength of an acid or a base is measured using a scale as a reference. It is called pH scale. In the pH scale, we have a value of 0 to 14, as you can see in the picture. On this scale, we can measure pH 0, which means it is very acidic, to the pH 14, which means it is very basic. The pH of a neutral solution is 7. It's the middle value. A value less than 7 represents an acidic solution, and a value greater than 7 represents it is a basic solution. Now, what is the importance of pH in our daily life? First one, sensitivity towards living organisms. Our human body has a pH range of 7 to 7.8, which is in somewhat neutral range. Living organisms can only survive a narrow change of pH. As you can see here, when pH of rainwater is less than 5.6, it is called acid rain. When that acid rain flows into a river, the river water becomes a pH value of lower pH value. Hence, the survival of aquatic life becomes critical and difficult. Next one is pH in our digestive system. We all know our stomach produces HCl, hydrochloric acid. It helps in digestion. During this process, at certain times, stomach produces excessive hydrochloric acid, which causes pain and irritation. This is called acidity. To overcome this issue, to prevent this issue, we intake antacid, which are bases, to neutralize the HN acids. So that is the pH in our digestive system. Next, pH change as cause of tooth decay. Tooth decay occurs when the pH of the mouth is less than 5.5. You all know tooth enamel is the hardest substance which is made up of calcium phosphate. It corrodes under the pH 5.5. Bacteria present in the mouth produce acids by degradation of sugar and the food particles remaining in the mouth after eating. So, it must be ensured that our mouth must be well cleaned. Toothpaste are really basic materials that neutralizes the excess acid which is present in our mouth and helps in getting us a stronger teeth and prevents tooth decay. Next one, self-defense by plants and animals through chemical warfare. If you was stung by a honeybee or a simple bee, there will be a kind of irritation or a pain causing at the bitten area. This can be overcome or this pain can be relieved by applying mild bases like baking soda, because that pain is caused by a typical kind of acid which is produced by the bee. This acid can be simply neutralized by a base like baking soda. Next, salts. This is the main topic in this chapter. A salt is produced as a result of neutralization reaction of acid and base. We have studied this. Salt of a strong acid and a strong base is a neutral salt with a pH almost equal to 7. A salt of a strong acid and a weak base is an acidic salt which having pH less than 7. A salt of a weak acid and a strong base is a basic salt with pH greater than 7. NaCl, the common salt. You might know sodium chloride is the common salt that we use in our daily life. It is an important raw material which is helping to prepare different kinds of chemicals in the industries which have varieties of uses in daily life and so on. NaCl is prepared by neutralization reaction of HCl and NaOH. As I said, it is the main raw material which is used in making several chemicals like sodium hydroxide, baking soda, washing soda, etc. Now, let's look at the important chemicals which are made from sodium chloride. First one, sodium hydroxide, NaOH. When electricity is passed through an aqueous solution of sodium chloride, NaOH is formed. The reaction is NaCl plus H2O gives NaOH plus Cl2 plus H2. Here, chlorine gas and hydrogen gas are formed. Chlorine gas is produced at the anode, hydrogen gas is produced at the cathode. This is an electrolysis reaction. The process is called chlor-alkali process. The main thing about this reaction is, here all the products are of some important uses. Sodium hydroxide, NaOH can be used widely, chlorine gas can be used widely, hydrogen gas can be used widely. Hydrogen gas is used for fuels, manganese, ammonia for fertilizers. Chlorine gas is used for water treatment, in making PVCs and used in disinfectants. NaOH is used in paper industries, in detergents and soaps, in degreasing metals and in artificial fibers. Next one is bleaching powder, CaOCl2, which is also called calcium hypochlorite. The chlorine produced in the previous procedure is used here, which means the chlorine which is produced in the preparation of sodium hydroxide is used here. This chlorine is allowed to act upon or is allowed to react upon calcium hydroxide, which gives CaOCl2 and water. As you can see, CaOH twice plus Cl2 gives CaOCl2 plus H2O. Bleaching powder is also the thing that we use in our daily life. It is used for bleaching cotton and linen in textile industry. It is also used in wood pulp in paper factories. It is used as oxidizing agent in many chemical industries. It is used as a disinfectant to make things free of germs. Next one is baking soda, NaHCO3. The chemical name is sodium hydrogen carbonate. It is produced by NaCl plus H2O plus CO2 plus NH3 giving NH4Cl plus NaHCO3, which means sodium chloride plus water plus carbon dioxide plus ammonia is giving ammonium chloride plus sodium bicarbonate. Baking soda has also wide range of characteristics and uses. It is used for making baking powder, which is a mixture of baking soda and a mild edible acid. As you can see, NaHCO3 plus H plus gives CO2 plus H2O plus sodium salt of the acid. CO2 produced in this reaction makes or causes the bread or cake in the making them soft and spongy. It is also used as an ingredient in antacids. It is also used in soda acid fire extinguishers. Next one is washing soda, Na2CO3.10H2O, which is sodium carbonate hydrate in the hydrated form. On heating baking soda, sodium carbonate is formed, which on recrystallization gives washing soda. As you can see, what is heating baking soda is NaHCO3, sodium bicarbonate is allowed to heat. We are getting sodium carbonate Na2CO3 plus H2O plus carbon dioxide. This Na2CO3 is allowed to recrystallize and we get the hydrated form, which is Na2CO3.10H2O. This is washing soda. It is used in glass, soap and paper industries. It is used in the manufacture of sodium compounds such as borax. It is also used as a cleansing agent for domestic purposes. It is also used in removing permanent hardness of water. So these are the different kinds of chemicals that we are obtaining from common salt or that we are preparing from common salt. Now, water of crystallization. Water of crystallization is simply the fixed number of water molecules present in one formula unit of salt. This can be made clear with the help of an example. As you can see here, both these are copper sulfate crystals. But we don't know what is this white color. Copper sulfate crystals are blue in color. When we heat, the color is lost and compound turns white. This is because the blue compound is in the hydrated form, which is CuSO4.5H2O. This is the pentahydrated form. When heated, this water, which means the hydrated form, is removed and the white color appears. When moistened again with water, the color is restored. So this is the water of crystallization. Next one, plaster of Paris, CaSO4.12H2O. The chemical name of plaster of Paris is calcium sulfate hemihydrate. This is made from gypsum. Gypsum is heated at 373 Kelvin. It loses water molecules and plaster of Paris is formed. Plaster of Paris is widely used by doctors as plasters for supporting fractured bones. It is a white powder. How they use is that the white powder is mixed with water. It is converted back to gypsum and now it changes to a hard solid. As you can see, this is the procedure how they put plaster to a fractured bone. CaSO4.12H2O plus 1.5H2O giving CaSO4.2H2O, which is gypsum. Plaster of Paris is widely used in different applications, as you can see here.